Welcome to AI Frontiers, where the latest advancements in artificial intelligence and robotics are explored. Today's episode delves into groundbreaking studies published on May 14, 2025, focusing on innovations in autonomous navigation and human-robot interaction. These studies highlight key themes, methodologies, and future directions in robotics, bridging artificial intelligence, mechanical engineering, and real-world applications. Robotics within computer science represents a multidisciplinary frontier, integrating artificial intelligence, mechanical engineering, and electrical engineering to solve real-world problems. Applications span manufacturing, healthcare, and autonomous vehicles, pushing the boundaries of automation while presenting both ethical and technical challenges. A significant research theme is the integration of edge computing and artificial intelligence to enable real-time decision-making in dynamic environments. Emory Gurjan and colleagues demonstrated this through drones using lightweight processing for obstacle detection. Edge AI replaces cloud-based systems, reducing latency in critical scenarios and highlighting computational efficiency and scalability for resource-constrained platforms. Another prominent theme is multi-modal sensor fusion, creating context-aware robotic systems. Pranav Mahajan and his team linked sensory feedback to movement primitives for adaptive control. This approach combines data from cameras, tactile sensors, and more to provide robust perception, enabling robots to learn tasks through experience rather than pre-programmed rules. Terrain adaptation and skill learning represent crucial areas of focus. Kasi Vishwanath and colleagues developed Trailblazer for off-road navigation using multi-modal data, while Michael Burgess and his team advanced robotic manipulation with innovative grasping mechanisms. These efforts emphasize adaptability in challenging terrains like lunar or Martian surfaces. Key findings across recent papers include breakthroughs reshaping robotics. Rayuna Karagudra Jayanth and colleagues reduced trajectory error by 21% using event-based sampling. Xianfan Zhang and colleagues achieved over 90% success in unseen peg insertion tasks with Vision-Tactile-Language-Action models. Emory Gurjan and his team showcased computational efficiency in edge AI-enabled drones. To tackle complex challenges in robotics, researchers employ various methodologies. Imitation learning transfers human expertise but struggles with environmental variations. Simulation-based training accelerates testing but faces reality gaps. Reinforcement learning enables sequential decision-making but requires careful reward design. Pranav Mahajan and colleagues introduced Neural Associative Skill Memories, a framework linking movement primitives with sensory feedback. This system demonstrates fault detection and adaptive control in dynamic environments, offering implications for prosthetics, rehabilitation, and autonomous systems. Kasi Vishwanath and colleagues presented the Trailblazer framework, revolutionizing off-road navigation. By combining imitation learning with differentiable A-star planning for cost map generation, Trailblazer achieves robust performance across diverse terrains without manual tuning, opening possibilities for agricultural robotics and planetary exploration. Shivin Das and colleagues introduced the DataMIL framework, optimizing data selection for robot learning. Using policy-driven data selection, DataMIL improves task-specific performance, outperforming traditional baselines in simulation and real-world tasks, highlighting efficient utilization of large-scale datasets in robotics. Future directions in robotics involve addressing challenges and unlocking potential. Bridging the sim-to-real gap with advanced transfer techniques, improving computational efficiency for lightweight platforms, and exploring hybrid approaches combining model-based and learning-based methods are promising avenues. This presentation was synthesized using Qwen-Max TTS via Deepgram and image ideas via Grok. It was reviewed by human experts, though some oversights may exist. References are provided for all cited papers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.